In this lecture, we will continue with ICMP messages used for error handling and debugging of internet. So this time we will look at ICMP query message. Okay. So what are ICMP query message? So they are used for debugging. Okay. So first one is ICMP echo request message that can be sent by a host or a router, and this is one of the very important messages which you are using a lot, and that is in ping. Okay, so you ping a machine, you always say, okay, I'm pinging you. In fact, it has become a very local word for many engineering students. Okay, ping. So which means that I ping a host, that is, I am asking, are you alive, are you still there? Okay, so ICMP echo request is the message used, and if the other host is there alive, it will send an ICMP echo reply. So both of these are ICMP message. So an echo request message can be sent by a host or a router, and echo reply message is sent by the host or the router that receives this echo request message, and it will just tell that, okay, I'm there, yes, you have requested me, that am I there? It will send yes, I'm there. So echo request and echo reply message can be used by network managers to check the operation of IP protocol. That are the two, in fact they are used to find that operation of IP protocol. So are they connected? Okay, that is also important. So are they connected? Is there the link working? Is this alive? And means this logical and, is the link working? So you cannot contact this host B, A cannot contact it if this is broken or if it is not alive. So it checks both of them, and if both of them are true, you get a reply back. So let's move forward. Echo request and echo reply messages can test the reachability of a host. This is usually done by invoking ping command, which you do always. So what is the type? So type 8 is echo request and type 0 is echo reply. Code is 0. So here you have then checksum, and you have an identifier sequence number and some optional data. Okay, sent by the request message, repeated by the reply message. So let's look at some example. Then there is timestamp request and timestamp reply. So this is another query message. So timestamp request, I request the other computer that, okay, please send me your time on your computer, and it will reply with me with the timestamp reply. It will send me the time now. So its type of request is timestamp request as type 13 and reply as type 14. Code is 0. Original timestamp is sent, receive timestamp is sent, transmit timestamp is sent. Okay, so original timestamp, I mean that it will be what I have sent, you whatever is the timestamp at your place, receiving timestamp, and then the transmit timestamp is there. Timestamp request and timestamp reply messages can be used to calculate the round trip time between a source and a destination machine, even if their clocks are not synchronized. Okay, so is it so? So they are saying that timestamp request and reply messages can be used to calculate the round trip time. How much time is it taking? And even if the clocks are not synchronized. So what can be done? So if we have, I put my timestamp here, he has his timestamp here, he puts that, okay, it is, let's say a counter is running which is 1001 here, and then a reply comes here. So even if it is not synchronized, then timestamp can be used. So how is that possible? Let's try to see the next slide. The timestamp request and timestamp reply messages can be used to synchronize two clocks in two machines if the exact one wait time duration is known. Okay, so it can do other thing looks fine, that okay, if I know the transit time, that how much I take, then I can synchronize my clock. I can ask him what is the time at your clock. Then when it comes here, I know that the propagation delay is, let's say, 100 millisecond. It says that okay, it is 1 o'clock exactly at my watch. Then when it comes here, okay, then I know it is now 1 o'clock plus 100 millisecond. Okay, so this is looking fine. Other was that even if the two clocks are not synchronized, you can find the round trip time from here. So let's see what are the fields that were available. So it is claiming that. So original timestamp, received timestamp, and transmit timestamp. These three timestamps are given, and you have to calculate the round trip time. Original timestamp, I can send a request, I can put my timestamp that okay, it is, let's, I will put very large value, so 3 o'clock here at my side. Received timestamp, the other party will in the request, so he will know that okay, let's say his clock was not synchronized, he says that it is 4 o'clock. Transmit timestamp, now what it does, so this I will leave it to you to reply me back how is it happening. So this will be your homework when teachers, so they don't know, they usually put it that way, that okay, please solve this question for me. Okay, so you also do that thing. Now let's move forward. So we will move to now some of the debugging tools, and as I had promised, we will look at ping and traceroute. So they are interesting tools. So one is ping to see the reachability, and traceroute will find for us what are the different routers through which a packet goes. Okay, so let's look at ping and traceroute. So ping, let's see, ping fhda.edu. So what will be the result? This will ping the server fhda.edu. Now what happens? Oh, sorry. So it will ping, and you will see an Icmp sequence number 0. So it sends 5 packets. Okay, TTL is 62. Round trip time taken is 1.91 millisecond. Okay, so this is what, so time taken from transmit. So it tells that okay, this, it is sending in fact 11 packets to the fhda.edu server, and replies are coming back to it, and then it says that okay, I got, this is the statistics, 11 packets were transmitted, 11 were received, 0% packet loss, time is 10103 millisecond. Okay, someone is coming. So RTT, minimum, average, and max settle. So the minimum round trip time was 1.899 millisecond, max average is 1.955, and maximum is 2.041 millisecond to reach the ping it and let the reply come back. In our next example, we want to show if Adelphia.net mail server is alive and running. We want to check that. So mail server you denote by mail.adelphia.net, is it alive? The result shown is here. In this case, 14 packets were sent, only 13 were returned back. One might not have replied, may have interrupted the program before the last packets. Okay, so see, so I'm sending sequence number 0, 1, 2, 3, 4, and what happens now is that for one of the packets, 14 packets I sent, but for one the reply did not come back, the sequence number 13. So it now finally tells that 14 packets were transmitted, 13 were received, and there was one packet loss, which comes out to be 7% packet loss. Okay, so this is the difference here. Now we will study traceroute. Okay, this is a very interesting concept, and how it happens, let's try to see. So what we do, it also is done using Icmp. So what happens, that I have, let's say this is the sender, some routers and destinations. So I will call it router R1, R2, R3, R4, and R5, R6. So now what I do, I will send packets. Okay, for finding what is the routers number 1, what is the second router in the path, third router in the path. So I will send IP packet Very intelligently, I will put initial TTL for the packet equal to 1. So when it comes to this router, TTL becomes 0 because it is decremented. It will R1 will generate an ICMP error message saying that okay, TTL became 0, so time exceeded message. But from here the source will be R1, so I will know that okay, the first router in my path to destination D is R1. Then I will send another packet with TTL equal to 2. It will traverse this, TTL will become 1, it will go to this place, TTL will become 0, and then this will send an ICMP message, source is equal to R2, time exceeded. So now I will know that okay, R2 is the second router. Then I will make TTL equal to 3, send again, so 1 2 3, so it will 3 to 2, it will become 2 to 1, 1 to 0. So R3 will now send a time exceeded message. I will know that R3 is the third router. Similarly, if I set TTL equal to 6, so 6 will become 5 here, 4 here, 3 2 1 0, so it will become 0 at R6. So sixth router in the path will send us the ICMP time exceeded message, and from those sources I will know that these are the routers in the path, and it helps in tracing the routers in your path. So let's try to see. So Traceroute we do, so fhda.edu, so it is just 3 hops, dcore.fhda.edu, dbackup.fhda.edu is the second router, third is tiptoe.fhda. So this is the router path for our Traceroute. A longer path is there's to xerox.com. I have 9 routers in the path. So it tells me that okay, what is the IP address, what is the name, and how much is the time in. This is something like all these 3 in milliseconds. So what are they telling us? Okay, so they will tell you, so in fact they're decreasing, so might be the maximum round trip time. Okay, then millisecond, this one is average and this is minimum and so on. Okay, so this is there. Then an interesting point, it says it can be done, Traceroute can be done to yourself also. And then one thing very interesting is that if many times what happens, many routers don't generate ICMP messages also. Okay, so because there are many routers inside autonomous systems, ISPs, for which they don't want to reveal the IP address. So then what will happen? They will not send any reply. For them we will put a star that okay, I don't know what is the IP address for that particular router. Okay, so I hope you now understand what is traceroute command. So thanks a lot.